Hello friends, welcome to Secret of Electronics. In this video, we will learn how to make a commercial level WS2812 Neopixel LED controller using the 8085 microcontroller. The circuit diagram shows a WS2812 Neopixel LED controller using a 8085 microcontroller. The 8085 is powered by a 5V DC input which is regulated through a Schottky diode D1 SS34 to protect against reverse polarity. The WS2812 LED strip is connected to the 8085 with its data input D-in connected to PV1 of the microcontroller. Additionally, a SST1306 OLED display is interfaced with the 8085 by the I2C protocol, with SCL connected to PV2 and STA to PV0. Two push buttons SW1 and SW2 are connected to PV3 and PV4 through 10 kΩ pull-up resistors R1 and R2 to allow user interaction. The circuit is designed for controlling WS2812 LEDs and displaying relevant information on the OLED screen. This Arduino code is designed to control a WS2812 NeoPixel LED strip using a 8085 microcontroller, allowing users to adjust the RGB color values and the number of active LEDs through two push buttons. The select underscore button connected to pin PV3 is used to cycle through different settings including red, green, blue and LED count, while the set underscore button connected to pin PV4 increments the currently selected value. The number of LEDs is limited to a maximum of 100 and the default setting initializes only one LED. The Adafruit NeoPixel library is used to control the LED strip, while the TinyWire M and Tiny 4K OLED libraries manage communication with the SST1306 OLED display, which provides a visual interface for the user. During setup, the code configures the push buttons as inputs with internal pull-up registers and initializes the OLED display. The program then loads previously saved settings from EEPROM, including the last used RGB values and LED count. If no saved data is found, default values RGB equal to 0, LED count equal to 1 are used, and these are stored in EEPROM to initialize the system for future use. The WS2812 LED strip is set up with the specified number of LEDs and a initial color update is performed. In the main loop, the program continuously checks for button presses. If the select underscore button is pressed, then the color index variable is incremented, cycling through red, green, blue and LED count settings. If the set underscore button is pressed, then the program updates the corresponding value. For colors, the selected RGB component increases by 25 until it wraps when exceeding 255. For the LED count, the number increases by 1 until it reaches the maximum limit, then resets to 1. The LED strip updates immediately with the new color values, ensuring real-time feedback. Additionally, every change is saved in EEPROM to retain settings after a reset or power cycle. The OLED display provides a user-friendly interface by showing the current RGB values and the number of LEDs. It also highlights the active setting using a cursor, making it easy for the user to identify which value is being modified. The update OLED function clears the screen and redraws the updated values, ensuring clarity. The update LED function applies the new color settings to all active LEDs in the strip, ensuring uniform. Program also includes a re-initialize LEDs function that resets the LED strip when the number of active LED is changed, preventing unexpected behavior. To ensure that the settings persist, the save settings function writes the current RGB values and LED count into EEPROM. When the microcontroller restarts, then the load settings function rederives these values, ensuring that the user's previous preferences are restored. If the EEPROM data is invalid or corrupted, then the program resets the settings to default values. This approach makes the system more user-friendly and reliable even after power loss. Overall, this code provides a efficient and interactive way to control WS2812 LEDs using a 8085 microcontroller. It allows users to adjust colors and LED count using simple push button inputs while offering real-time visual feedback on the OLED display. The use of EEPROM ensures that user preferences are retained, making the system ideal for standalone LED applications such as decorative lighting or custom LED controllers. Now we will use the Arduino Nano board as a ISP programmer to program the 8085 microcontroller. We need to connect the ISP pins of the 8085 microcontroller to the ISP pins of the Arduino Nano board according to the circuit diagram displayed on the screen. If you are unsure how to program the 8085 microcontroller using the Arduino Nano board, then you can watch our detailed tutorial by clicking the I button. Now open the Arduino IDE and install the Adafruit Neopixel, TinyWireM and Tiny 4K OLED libraries. As you can see, I have already installed all the required libraries. After installing the libraries, connect the Arduino Nano board to the PC using a USB cable. Once connected, open the code file which you can download from the link given in the description. After opening the code file, select the correct settings under the Tools menu. Once the correct settings are selected, click the Upload button in the Arduino IDE to upload the code to the 8085 microcontroller. Now that the code has been uploaded to the 8085 microcontroller, connect all the components according to the main circuit diagram we discussed at the beginning of this tutorial. I am using the BOK-V simulator because the WS2812 Neopixel LED is not available this time. After connecting all the components, you can see that we can set the NeoPixel to any color by changing the RGB values. Additionally, you can also change the number of LEDs using the same push buttons. This allows us to set the number of LEDs according to the number of LEDs present in our WS2812 NeoPixel LED strip. If you liked this video, do not forget to subscribe to our YouTube channel to watch our upcoming interesting tutorials.